Hey guys, Mrs.Bodechon here, and we are doing part 2 of AKS 8A. Let me try to find a good spot. Here we go. So that you can see this graph really, really well. In fact, let me see if I can just move it. Yep, there we go. Move it over just a little bit for you. So you are looking at what's called a distance time graph, okay? And what do we know we can calculate when we do distance divided by time? As you just learned, we can calculate speed and we can calculate velocity as long as we add direction on there with it, right? So when we look at this graph, we know we can get that information. We're going to talk now about the basics of what these lines represent when it's on a distance time graph. Notice first, time is on the x-axis and distance is on the y. That's important when we start to look at these lines. Now, if you look at this green line, it's linear, right? And it's a straight line in positive direction. We know from looking at this, as distance increases, time is also going by, right? Now, because this line is so steep, right? It's such a steep line, we can say this is going really, really fast because it's covering a whole lot of distance in a short amount of time, right? So this is a very fast line, but it's also a steady or constant speed because it's straight. Okay, as distance is being covered, time is increasing at a steady rate, so it's constant as well. Kind of like cruise control on your car, but this is going extremely fast, like really fast cruise control. Now, if we look at this blue line, it's going to be getting faster or accelerating. So when you see a curved line, that just means that we are actually having some acceleration happening. We're getting faster when it's a positive curve like this. Now, if you see this red one, we have 3 line segments and they each mean their own thing, okay? So the first line segment that you see right here is kind of a medium slope, right? It is constant because it's still increasing distance as it's increasing time at the same rate. So I do have a constant speed, but it's not going super fast, right? If it had a much steeper slope like this green line, where it's almost up and down, if that means fast, and this one is a little bit lower. So this is just a steady speed. It's constant speed, but it's going like a moderate speed, all right? As I get closer and closer down to the x-axis with my lines, it means I'm going slower and slower, okay? Because eventually, if I reach the x-axis, it means I'm not going anywhere at all, right? That's like my starting position. So if we look at this flat line here, it does say stationary. Stationary just means like at rest or not moving, right? So time is still passing. If you look on our graph, time is still passing, right? But they're not moving anywhere. They're not going further away from where they started. They're not going closer to where they started. They're not going anywhere. They're staying in the same location. However, time is still passing by, all right? Now, this final line, this line right here, a lot of people look at it and they're like, oh, it means you're slowing down. It actually doesn't mean you're slowing down, okay? What it means is you're going back the way you came, okay? So you're doing it in a fashion where it's a straight line, which means it's a steady speed, right? And because it's a moderate slope, it's a moderate speed, right? Remember, the steeper the slope, the faster it's going, okay? So this is a moderate slope, so it's a moderate speed, and you're going back the way that you came. So I want you to look at this on your sheet, and let's see if we can figure this out together. So we have a graph that looks somewhat like what we just looked at, a little bit different, and we have these 3 scenarios, and we have to determine which story matches our graph, right? So let's look at A. It says, Tom took his dog for a walk to the park. Well, if I'm starting right here and I took my dog for a walk should be a line that looks something like this. It's going to be a very shallow slope, okay, because it's slow. And, well, this line is pretty steep, right? So I already know A is not the right answer because it starts off with a walk and not like a jog or a run or something that's going to be a little bit faster. So I can go ahead and I can cancel this one out, but we'll go ahead and read the rest. It says, he set off slowly, then increased his pace. At the park, Tom turned back around and walked home slowly. So if Tom would have set off slowly, it would have been a shallow slope, right? And then increased his pace. The slope would have gotten pretty dramatic. And then at the park, Tom turned around and went back home slowly. And when he goes and turns back home, it wouldn't be so steep. It would be much more shallow because he's going back home slowly. This is pretty steep, okay? So let's look at B. Tom rode his bike east from his home up a steep hill. After a while, the slope eased off. At the top, he raced down the other side. This story paints a picture of what this hill looks like in your mind. And you know what that hill looks like? It looks like this picture, this graph. If your mind gives you an image of a mountain or a hill because it's painting a picture in your mind, it's almost always wrong because this is math, okay? And so we need to think about it mathematically and not in an imagery way. So if I'm looking at this, it says he rode his bike, which, okay, sure, that's fast. He rode his bike. Okay. After a while, the slope eased off, which means he got slower, right? All right. And then at the top, he raced down the other side. So we're good up to here. But then it says at the top, he raced down the other side. Although this looks like, oh my gosh, he went down the hill. No. You guys, if I start at one side of a hill and I go up it and then I go down it, I'm further away from where I started, right? I went even further from my starting point. So my graph would be going up, not down. It would be going a greater distance, not a less distance, okay? So that's where this graph is wrong. It would be going upwards with the same kind of slope, right? Because he's racing down. So it would be a steep slope, but going up. So the answer is C. Tom went for a jog, which is a quick slope, as you see. At the end of his road, he bumped into a friend and his pace slowed. So he bumped into his friend here. His pace is slowing. He's probably talking to his friend, right? When Tom left his friend, he walked quickly back home. So we see that it's a quicker motion and he's returning the way he came, right? He went out for a walk. Now he's coming back home where he started from. So he started here. He ended up here in the same distance at 0, okay? So the next one that you guys have on your sheet looks like this, and this one is completely different. This one is a velocity by time graph. So all the rules you just learned don't work on this graph at all. What can we figure out with velocity and time? We can figure out acceleration. So we're going to use this graph to calculate acceleration by pulling data numbers and by doing some mathematical equations like we've already done in part 1, right? So let's look at what these lines mean. Try to get this a little bit out of the way. Okay. So first of all, notice time is still in the X and velocity is now in our Y. So now we're thinking speed, right? Velocity, speed versus time. So our first line here, this blue one, is acceleration. So notice it's a straight line, it's constant, but it's no longer constant speed. It's accelerating, which means it's speeding up. This is like if you're in a car and you push down on the gas pedal, your car is increasing speed with time. And that's exactly what we're doing here. We're getting faster as time is moving forward, okay? Now, this next one, this red line, it says steady speed. This is now your cruise control. This is where you're the same speed for a given amount of time. So, for example, this one says 20 meters per second, right? So this red line is 20 meters per second for 40 minus 20 for 20 seconds. So for 20 seconds, if this is a car, this car went 20 meters per second or whatever it is, right? Skateboard, whatever, okay? Now this green line is deceleration. Remember that deceleration is a form of acceleration. Deceleration just means that you are slowing down, okay? So you are decelerating or slowing down. And that's exactly what we're seeing here. We just went from 20 meters per second to 10 meters per second. So now we're just slowing down at a constant rate. Now, if you can see that we have this other blue line, it says increasing acceleration, and this is increasing acceleration just like this one is. The difference between a straight line and a curved line is this one is accelerating at a constant rate, and this is accelerating at a changing speed, right? So this is like maybe you're pushing on the gas pedal a little bit, and then you're pushing on the gas pedal harder, right? So it's at a changing rate. So that's the difference between those two lines. But hopefully this was helpful to understand these graphs more, you guys. And we will practice pulling off some of the numbers that I just showed you and actually doing the math calculations for acceleration, for speed, and for velocity as well.